Nowadays, statistical quality control is essential in the industry because companies want to have control of their processes to manufacture safe and quality products, satisfying the requirements of their customers at the lowest production cost. Also, quality has become one of the most important consumer decision factors in the selection among competitive products and services. Understanding and improving qualities are key factors leading to business success, growth, and enhanced competitiveness.
The main objective of this project is to investigate and analyze an industrial problem with statistical quality control tools to obtain the necessary information about the process and determine if it is under control or not. To achieve this objective and have a better presentation of the problem development, the project is divided into the following points: a statement of the problem, review of literature and method, results, discussion, and conclusions.
We are integrated by Eckamn Rodríguez,
Rivera,
Alejandro Castro,
Cynthya López.
Problem statement. Nowadays, there are so many brands of dog food with a wide variety of prices that it is why a product quality is a trigger for a consumer to choose the brand. A big challenge consists of meeting the expectations of shapes, textures, colors, and aroma of food. If this is not achieved, the product will never be offered to the pet, in addition to meeting the nutritional requirements for which the food was designed.
In this context, we should ask if we can evaluate the possibility of improving the process of packaging sacks of dog food.
The objective is to identify the possible errors and variation indicated by the control charts so that we can increase the quality of the product.
For that purpose, 10 workers took 10 samples of the weight of the food to analyze if the packaging process is under control.
Literature review. The definition of quality is when one or more desirable characteristics that a product or service should possess. This has become one of the most important customer decision factors in the selection among competing products or services. The statistical process control is the quality branch that consists of the collection, analysis, and interpretation of data. Stability allows forecasting the performance of the process in future executions and elaboration of achievable plans. The statistical control is widely used to understand and decrease the variabilities of the process, with the main objective of bringing the process under control. A control chart is one of the primary techniques of statistical process control. There are two types of causes for variations in a process or product: special cause and common cause. Process capability analysis compares the output of an in-control process to specification limits by using capability indices. These indices are powerful means of studying the process ability for manufacturing a product that meets specifications.
In this context, we should look for a method. So first, we search and chose an industrial problem that gives us enough information to analyze it based on the statistical quality control. To use the statistical quality control tools in an easier way, we decided to use the Minitab software, in which we put the data provided by the problem and obtain the results using the tools. So those are our results, and to evaluate the performance of the processes, 10 different sets of samples each were randomly selected on day 1 on different moments of the working day.
If the expected mean was around 23.45 kilograms, we would be able to say that there is an not much variation since all the values fall within the control limits in the X-bar R chart. In the R chart, we first determine whether the variation of the process is under control. Since all the values of the R chart are within the control limits, we can examine the X-bar chart using the control limits because they are accurate. In the X-bar chart, we can see that the entirety of the means fall within the control limits. Therefore, we could conclude that there are no special causes of variation and that the existing variation is due to the nature of the process. However, from analyzing the X-bar graph, we can observe that the samples are all significantly far from the expected mean of 23.3 kilograms. Besides, there are 3 sets of samples whose mean falls above the upper control limit. This means that there are special causes of variation that need to be identified and corrected.
The value of CPM is 0.66 and for CPK it's 0.58. Therefore, the process is not very well centered on target, but it's near to it. Generally, higher CP values indicate a more capable process and lower CP values indicate that the process may need improvement. In this case, the CP is 0.83. Therefore, it indicates that the process is not adequate to work and it needs to be improved in order to reduce its variation. In this case, CPL is equal to 1.08 and CPU is 0.57. Therefore, the process is not centered. It is important to mention that a small part of the process distribution will be outside the process specification limits, especially in the upper limit. When comparing CP and CPK, they must be roughly equal to assert that the process is centered. In this case, the 2 values are not the same. Therefore, the process is not centered between the specification limits.
On the first day of sampling, we observed that the process was far from the spec target and that strict measures has to be taken to improve the capability of the process. We obtained a CP smaller than 1, which was not a good indicator to achieve the target. Improvement activities were carried out to get better results of the 6th day. On the 6th day, the CP was 1.83, which is higher than 1.33 and almost equal to 2, which means that the process was highly adequate. Now the process is centered on the target of 23.3 kilograms.
Well, the main reasons why the process was performing poorly were that the machines were not gauged correctly and they were not cleaned properly. The machines were gauged to the requirements of the production and the maintenance personnel were instructed on how to clean the machines properly, and this is how the process improved significantly. There was also a lack of supervision along the line, which resulted in production deficits that were not detected timely. Then, in the part of conclusions, the main objectives of the project were achieved, like the problem statement, literature review, the method, results, discussion, conclusion, and also the reference and a good teamwork. The basic elements necessary for statistical process control were presented and applied to evaluate the possibilities of improving our production process. The results show need for a more rigorous control of the quality of the inputs. Also, we can conclude that carrying out a statistical control analysis of the process allowed finding errors in the process and identifies that it was not under control in order to take measures to stabilize it. After the study, we can see how the weight of the bags of dog food is less variable and closer to the target value. In terms of contributions, I organized the work and looked for new opportunities after the project was sold, and also this project helped me to improve skills like communication, teamwork, competitiveness, and so on.
I helped to interpret the results. Also, I was concerned that things work out so that we can overcome difficulties and not waste time.
I seek for information. I was a positive person. I pushed the team forward. I strived for team success and got involved in the project.
I generate conclusions and look for areas for improvement.